Okay. So open up IO box more. If you open up the IO box more, as you can see some of these dots moving across with X position, and they are fixed into the Y positions. And with the switch, there are two different IO box. IO box. And if you click that IO box and they bring on inspector window, you can see I changed the option for slice count mode to the calls, rows, and pages, and I'll give the very specific number as 5. Okay? So if I change this switch into the 0, as you can see that even though I provide 10 different slides of information, they only gave out 5 slides, yeah? And then the effect on only 5 that things là, yeah? And if you click on the switch, it turns out it's normal state, okay? So if you click this one, they said 10. So even though you change that on 5, okay, the still account will be the 10, okay? So unless you change the option for slice and count mode as calls, pages, row and pages, okay? And if you change if you stick option for the input, the size of this spread will be determined by the input, yeah? But if you change the option, they no longer take input as the count, okay? They provide they data out only specific number of the counts of the slice. Yep. Okay, that is really important. So sometimes when you're doing that, yeah, for checking your input detail, but if you accidentally leave that option like that, you can't see the result what you expect. Okay, that is really important. So you have to bear in mind. Okay, so another one is also another basic things. Okay, let's see that. I spread count will be 5. Okay. So as you can see that with the random spread, I create very rough, the graph, yeah? So if you wanted to make a smooth transition between each point, there is a specific option which is called the B-spline, okay? So the way we use the B-spline is, this is going to be the control point for the B-spline, and then with that control point, and also you can provide another data set to divide into how many slides information you want to use. So we take this one as the control point. Just stop there. Okay, this is going to be the control point. Control point is going into the second pin of the control. Yeah? And the first pin is indicating the input. All right? So they recalculating control point location according to this amount of number, which is 100 at the moment. Okay? And then they do calculate based on these options, various options. These options. Show these options. Based on the degree, so degree means detail levels. How many detail you want to capture with that things. Okay. So if you give the more degree, if you increase the degree, they will automatically change very flat shapes. Yeah. It's a degree will be an acceptable number. So if I click that help file, they will explain blah 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 things. Okay, blah 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 things, and then you need to have a look. Yep, there's more detailed information in here, and then where we can use this kind of things is the really critical, and sometimes you can attach this spline information with the sound visualization, for example. Okay, so sound example, the data from sound analysis is always very cramped, yep, and very rough. So with that spline, we can create very smooth shape of the sounds analyzed, yeah. So then you can apply with this into the damper. Then, as you can see that they continuously, if I change the option like this, as you can see that they continuously draw the very, the smooth and rough, yeah, the shapes. Okay, so that is another important things we have to remember. Okay, and also, it's very useful when you doing that. Some of the data, for example, you're tracking the people and tracking some kind of electronic information. For example, if you wanted to use the sound the lighting detector, okay, they normally provide you very cramped range of the information, and with this spline you can little bit thought or smooth the data set. Right? So that is basic things. So in these examples, you have to remember that this slice count option is very important. If you make that option to the calls, row, and pages, the slice count will be affected by this number. And if you change that option into the input, even though that number will affect how many spread you can see, but actual number of this spread will be different. Okay, it depends on how many input you will provide. Okay, that is important. All right, so that is important. So now let's close this and open up another one. So can you guys open up dynamic arc V4P? Okay, dynamic V4P. Okay. In these examples, I use the grid segment, but as you can see that they have the very equal width of each segment, grid segment. All right. So we're going to discuss this one first. Then, after we understanding with this some kind of calculation logic, then we can build up this one, and then we need to turn this one into soft patch. Okay. When you wanted to make the soft patch, you need to provide another option another patches, another node in these examples. I'm going to discuss that things a little bit later on. First, we need to, I'm going to explain something about that kind of things. It's very important. All right, I'm going to create a new patches. New patches. And create the renderer. Okay, and then make this one bigger. And attach it to aspect to latio and provide here. Okay. So you don't need to make that big because, but I need to because I wanted to show something. All right, so now we need to create the grid segment. Okay, grid segment, and I'm going to attach this one to there. Okay, that's a grid segment. Grid segment has some resolution X and resolution Y. So if you want to make a smooth shape, you need to provide high number of the X resolution. Yes. So if you provide the 30, maybe, huh? Why? Okay, I'll show you that. That's a good question actually. So if you link that render state and if you turn into the wireframe, okay, that is, at the moment they have only one sections, right, like this. But if you change the Y resolution 3, they will have another layer here, okay. So that might be the very important. So if you wanted to turn this segment shape into like point, okay, or wireframe, maybe, or you can, if you wanted to provide, the multiply different color, but grid segment itself, they take just only one color, but it's going to be meaningless. But if you wanted to use, point, for example, can you see the point there? Hopefully you can. So now if you provide the resolution like, the 17, something like that, you can have the very many different, the point, right? And also we can use this point as in case some same scenario like a tractor we used before, right? Or you can rotate that things in different, the z axis, and then turning around, something like that, and then you can have the very dynamic cloud shape of the point, okay? But if you wanted to use just a normally solid, you don't need to be changed that numbers, right? So we stick on to the number 2, all right, at the moment. We only have, as you can see that, we only have this kind of things. Okay, so another option for that, another option for the grid segment, will be inner radius. Okay, inner radius. So if you change the inner radius, okay, you can see some, something is going on, right? I need to discuss this one first. And also, if you change that cycles, okay, cycles, we can have very, half of these half, we can change it in the arc shapes, right? Okay, so we're going to use this cycle, and also we're going to use the radius, okay, to create something like this. Okay, so what I want to show you is, let's change into the solid. Okay, so if you change the radius into 0.5, okay, 0.5, can you imagine, or can you calculate the, so now let's make the term. So now we can say this one as the width, okay, width of the arc, and this one is inner circle, right? Okay, so that is our terms. We're going to use that. So the size from here to there is a size 1 at the moment, right? And if you provide this one inner circle 0.5, okay, that means whole size of the inner circle is 0.5, okay, and the radius will be half of the inner circle size. Okay, I'll show you that. Color. Okay, so color. And then I'm going to create another code. This one is for demonstration. Okay, demonstration. So if I attach this one on top of there, and then, okay, so now this is, the one by one, yeah, normal size. So, and if I provide translate to D, and if I change the shape in half size, okay. Okay, so now this is inner circle size. So now we can easily guess the size of the width, stroke width, yeah? It will be half of the radius, inner circle radius, right? Okay, good. Good. Clear? Okay, so also another important thing is, okay, yeah, okay, that is. So, as you can see here, this example, okay, they have the same stroke weight. They have the same stroke weight. How we can calculate the same stroke weight? They have the different size of the circle, okay, outer size. And then they have the different size of the inner circle, but somehow they have to produce the same size of stroke weight. How we can calculate? Okay, so that is sometimes POBI is a really good tool as long as we provide the right method for the calculations. So here I draw some equation, okay, how we can calculate equal size of the stroke, okay, and this formula actually turn into there, okay, is this formula expressed like these very simple patches, okay. Once you attach this patchy into there, you will see the same things is going to be happening. Okay, I'm gonna enlarge this size. Okay, some detail. Yeah. Is it big enough to see? All right. Yeah. So, formula to calculate inner circle radius. Okay. So, as we mentioned before, radius multiple inner circle radius is ratio actually. Okay, so it is gonna be, so for example, inner circle, okay, they do the same thing as center X and center Y. They apply as proportion. Okay, not exact number. All right. So if I change this one, okay, if I If I apply the transform here, let me get this one now. Okay, at the moment, I provide inner radius 0.5, yep. So if you change it at x scale, y scale, okay, as you can see that, yeah, they can apply that proportion in relation to the size of radius, the grid segment, okay? So that's why I said ratio, yeah? So if you want to calculate exact number, exact size of this one, you need to apply that kind of things. Radius, multiple, and inner circle, ratio, and divide 2. Okay? Let's demonstrate to this one. Okay. This one. Okay. So now this is going to be, how much was that? So 0. This width. Yes, 0.25, yeah? So, 0.25. So, where is? So, and also I said the radius, okay, not size. Okay, so the radius will be half of the size. Yeah? Yeah? Okay, yes. Huh? So half of the size. So this is Z1, and radius is here today. Okay, radius is here today. So if we agree this one, okay, we move on to the next one. All right. Next one is we resolve that equation. Okay. So if we want to rearrange this equation in relation to the radius, we can have this one, right? It's a basic equation. I don't need to explain that, right? Yes? Good. And then if we rearrange this one into the stroke weight, we can have this one, right? And then we can clean it up a little bit more. Okay. We can clean it up more. So now, like this one will be formula for stroke weight. Yes? Stroke weight is blah, 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 blah. But there is no space we can provide the stroke weight. Okay? We have to delimit stroke in relation to inner radius ratio, right?
When you say stroke here,
this one. Okay, stroke weight. All right, so we need rearrange this one in relation to the inner circle, yeah, inner circle ratio, and finally we can have something like this. Yeah, that is basic, equation resolve and arrangement kind of stuff. So now we need to express this one with Kobe note. Yep. Yep. Okay. So here, this one is, as you can see here, 0.5. This is arm size, so you can provide this one is a little bit change. Okay. And also this one is this bit is the same as from here to there. Yeah. So we can get some information here, and then we can multiple with the stroke. This one is a stroke actually. Yeah. All right. And then we need to divide into the radius. So this will be the radius value, right? Yeah, radius value. And then we need, this one is actually, this one is our, it's more like our, what's called, the target stroke weight. Okay, this one is our target stroke weight. Okay, so this one is our target stroke weight. So in this case, I calculate the target stroke weight, divide into the half of the radius. Okay, if you divide the radius with steps, then you can have the unit size, right? So that is our target stroke. Yep, target stroke. And then we need to multiple. Yep, here. Look here, there. Okay, multiple. Yeah. And then we need to divide into that the radius. And then we need, the subsums with this one is with 1. Okay. So that is a little bit hard to understand at the moment because we never transfer the mathematical calculation format into 4B node. Okay, so let's create a new patch. Okay, let's create a new patch. Okay, and just double click with the left mouse. Okay, double click with left mouse. You do not need to save these patches. We just do some exercise. Okay, now 1 minus A, B, and C, and D, okay. How we can express this one with 4B node? Yeah. How we can do that? So that is exactly the same thing as when we calculate that formula. We need to do inside of the parentheses, right? Inside of parentheses first. And the multiple is first, and the next is divide. Then we apply the plus and the minus, right? So in this case, we need to create one node for this and one node for this, all right? So for example, so we're gonna provide this one, okay? So here A, and here it ups. So that is really important, okay? So if you wanted to do more complicated, the visualization, you need to understand how we can change this formula into the, code node, okay? So now we have two sections, one for this one and one for this one. Yep. And then we need to divide these two values. Okay. Okay. And then what we have to do is we need to subsum this value with 1. Okay. Right? So same things. So if you turn this one, so like I just to more calculate, then yeah, now you can understand that, right? This one first, and then divide that, and it will be subsum with this one.
What about how you came up with the equation radius equals to radius multiplied by inner radius plus structure?
We're starting from there. Okay? And we're starting from there, and we resolve that equation. That means we just repositioning the value. Yep, that is mathematical basics. Okay? So if you rearrange this formula, okay, this equation with the radius, okay, this one and this one is exactly the same story, right? But we just rearrange. This one is a stroke, this one is radius. Okay?
I'm trying to rearrange it in my head, but I cannot get that formula.
Okay, so for example, let's skip to let's just skip to down there. Okay, so if you take that out, okay, so if you rearrange this one in relation to the inner radius, okay, I think you come up with this one.
Don't have the one.
You have to use the one.
Why would that be?
Huh? The one? Where is the one come from?
If you rearrange the top one, you get inner radius equals to 2 multiplied by stroke over.
Okay, look at that things carefully. Okay. So that is the formula, okay? The radius in the stroke, yeah? So if you wanted to take 2 out, yeah? We need to provide this one is multiple 2, right? Okay, so far so good? So far so good. And after that will be radius multiple in radius is a stroke. Yeah. Okay. So radius is a stroke in a stroke inner radius is a stroke yeah. So far so good.
That was what I required.
Yeah, so far so good. Okay, there is some okay. So why is one is come out? That's a good question actually. Yeah. In here, somewhere. Okay, so here. Okay. So there is, the trick things I didn't explain that. The radius, okay. If you apply this one to there, you can't have the stroke numbers, okay. But the radius itself, okay, radius itself is radius and inner radius ratio, yeah, and plus and stroke, so, yeah, that is radius size. Yeah. If you express another way, that is another size of the radius. Yeah. Because this one is proportions. Okay, this one is proportion. So if you multiple with the radius, and then if you stroke 2, yeah, that will be same as the radius size, right? Radius size. So I use this one to recalculate this one. So, yeah, okay. Now I understand. Now I remember that. All right. So with this one has a little bit tricky things, okay? Because so okay, just to forget about these two. Okay, that is how we can calculate the stroke. Yeah, and then also the radius. Okay, radius is the same as this formula. Right? Yep. Then if you rearrange that things, we have this equation now, right? Then we can apply this one to there. So sometimes it's really important what kind of mathematical formula you want to use. We can use this formula, but if you apply this one into here, it doesn't work. But if you use this formula, it will work. Okay? So you need to little bit try with the difference in the equation each time. Yeah? Okay. So anyway, so this one is, that you can apply the same things, like when you apply that central x, central y, center x, center y, that is only apply the proportion things, right? So everything is related to the proportion, so you can use this kind of things. So if you wanted to calculate, for example, x, for example, do you remember that the bar is spread around the circle? One of the examples I showed you that, yeah? So they, yeah. So it's like a circle and they x up, a little bit up with x things, okay? So we need to calculate that x up, right? So same things we can do like this way. Okay, because they use the proportion. Okay, so for example, if you change this one, it's x scale and x scale multiple with what? For example, the center x, yeah, that center x also applied in the proportion, right? And then we can add with that things, size of that things, so we can bring that. Okay. So, yeah, just remember this equation, and we can turn this equation into this part of that open node. Yeah? And then if you apply that, we can have multiple shape like this. All right. So now let's change this one to make that things happen. Okay. So this is a translate. Okay, translate. So we can make this a little bigger. Okay, bigger. Okay, so as we see that, we can calculate this one. We can apply this one first. So radius, radius mean is -1, -1, and then I'm going to copy this one. I want to use the occasion. Okay, so and the radius, which is radius, this one is the radius, so you divide into okay, so we're gonna provide the stroke weight and stroke weight and the multiple with the stroke weight and twice, and we need to divide this one with this one is the radius, and then we can provide this one to there, yeah, and then we can provide this one to here. Okay, so at the moment is the nothing is come up. Yeah, because we didn't provide the radius size. So if you provide 0.2 to 2.5, it will be exactly the same things happen. Yeah, this is okay, stroke size. Okay, this is stroke size. Yeah. So look at that. Okay, this is stroke size. 0.5, and this one is a radius value. If I directly provide radius value like that, it will be drawn like this, yep. And then if you provide this one into there, it will be provide the same things. But the good thing for this formula is we can dealing with this width, not the radius anymore. So if you change the radius value, this is going to be big. Okay, small like this. So that is, I think that is exactly 0.7. I think. Okay. So, but with this one, you really have to calculate exact amount of this stroke weight, right? So that's why we need this kind of things there. Okay. So now it's clear, yeah? Okay, so now we're gonna take a little bit away. So now what we have to do is we're gonna draw the multiple things, right? Not just the one arc. We're gonna draw the multiple arc. So for the multiple arc, as you can see here, we're gonna provide number, integer number, how many spread we're going to draw, yeah, how many stroke we're going to draw, okay, and arc count. Okay. And also we need the unit size. Okay, unit size. Yeah. So if you wanted to draw the 6 different arc, okay, they have the the certain kind of increment, yeah, in equal size. So this one we can calculate the unit size of the radius, and then we can do the multiple things with that and multiple. Then we can have the size of that each size. So we often use this kind of the formula. Yep. Yes. If you wanted to draw the small, bigger, the circle, we can provide this one, all right? But this time, it's a little bit changed, because if you provide starting from the 0, there is nothing can be drawn. So you need to start from the 1. Okay. So now we are ready to draw. And if you provide this number to here to there, okay, as you can see that they have 1, 2, 3, 4, 5. Yeah, different arc at the moment is there. And for the convenience, maybe we need to provide another color, each of them, each of arc. So let's provide the random spread count, and HSP, color joint, and there, and we can use the same account from there. So we need to extract information of the count from there. So now we can see that we have 1, 2, 3, 4 different color. Okay. Now what we have to do is, instead of providing just that one as the the radius, we need to provide this information. This information is radius. So we can connect this one to there. So we can have the equal size of that. Yeah. Things like this. So if you change a little bit, change the input of this count. So this is the value. So if you change this one a little bit, so we can see a little bit gap between there, right? Good. Yes. So now we are ready to turn this one into the subpatch. Okay, subpatch. Before we make the subpatch things, we need to provide another cycles. Okay, cycles. So let's have a look. If you provide here another random spread, and another damper. Okay, damper, connecting there and connecting there. And if you provide the discount to there, and famous RF4 trigger, and if you're connecting this one to there, you can see that they create the animation, something like that. All right. So I add a little bit animatic effect with the damper filter, with the random spread, okay? And I think you guys can come to this point if you little bit, think about how we can create that animations, things like that as the single object. Okay. Now it's time to how we can make this one into the sub patch. Okay, that is a little bit different story. All right. So just to save as this one into whatever you want to name. Okay, and I need I just give the my own names. So just save this one into a different name, and after take a 10-minute break, we're gonna come up with this one again. Yep.